So now we would like to talk about yield. So yield allows you to define a new type of object called generator functions. So yield is to generator functions what return is to functions. So let's look at an example that you can immediately understand because it's building on the previous one. So this example is called pour enumerate. It's on the left, and it takes as an argument a list called the list. And then it defines a counter, and for every element in the list, it will yield the counter and the element, and then it will increment the counter. Okay, so this behavior just does exactly the same thing as what enumerate was doing, except that we coded it in Python where it's not using a built-in, so it's going to be a bit slower. So let's see if we run over pairs I turtle in pour enumerate of turtles, we can print this and we get exactly what we had before. So what happened? Well, the big difference is that we didn't use a return here. If we had used a return, then counter comma element would have been returned the first time, and then that was it. That was all that was done, and then this part, for instance, would never have been executed. But there was not a return here. There was a yield. So a yield does different. It will, if you want, return the value counter element, but then instead of deleting all the different objects that have been created here and considering that we are out of the pour enumerate function forever, what it will do is it will pack up all the states within here, all the frame associated to pour enumerate, and it will be ready to call it again the next time we need it. So counter will remain over different calls of this pour enumerate part. So you see here that when we go over pour enumerate turtles, well, we'll go through the different Ninja turtles, right? Element will increase. We'll go over the different elements of the list, and each time we'll yield a new pair counter element, and counter will increase by 1. So that was for the Ninja turtle element. Let's look at Ninja turtle example. Let's look at another example that gives you basically all the cubes up to some upper bound. So I will here, okay, so I don't need this guy. I think there's a mistake here. So yes, so all the cubes up to 20, up to the cube of 20. And if I look at the type of C, I see that the type of C is now a generator. It's not a function. And I can ask for the next element in C. And the next element, the very first one, is 0. But if I ask for the next again, I get 1, and then I get 8, and so on. And if I ask for the list made of C, then I get this list of all the cubes up to 19 cubed, except that I've already spent some of the initial cubes here, so I only start at 64. So now if I call it again, I see that this list will be empty because I've spent completely my generator. I've gone through all the elements. There's nothing left. So this generator function here will only produce empty from now. Okay, but I could use that generator function to create a new generator, and then that's what I do here, and then call list on it, and I would have a list of all the cubes up to 20. So here is another way of using it. In a for loop, I can iterate over all the elements in my cube 20, and I can add 1, let's say. So those are all the cubes plus 1. Okay, so this was for a generator that had a specific length, but you could actually use generator functions that just keep on generating. They don't have an end. So I could just use this squares from. I guess it's called from because I had the intent, so let me correct this. So let's say there is an initial value, and this is the initial value. This is used to start the loop. So I could ask for the squares from squares from 25, let's say, and I would assign this to S. And then the type of S is a generator function. Yes, S is a generator, and the object that it uses to generate is square from. And then I can start asking for next. And I start at 25 squared, and then 26 squared, and then 27 squared, and so on. Okay, so I need to correct my example here to include 25. So this is fine, but then I could ask for list based on S, and what will happen? Well, it's trying to create a list of all the squares starting from, I guess, 25, 26 to the 28th one. So this list will never end. So that's what it's trying to do in memory. And I have to stop it with Control C. Okay, so I could do for X in list C, and then I could print X. And you, okay, now I've spent the, no, sorry, it was for X in list S, print X. And I've spent the generator, so I have to recreate it. And now I can do it for X in list C, S, print X. And right, so what happens here is that it's taking the generator and it's converting to a list, and it's already here that there's a problem. So it's never reaching the print X. But, okay, I really want to insist on this. So I can do squares from 25. And then for X in S, print X. And there it will start printing all the squares starting from 25. And it will keep on going forever, or up until it can't square anymore because it runs out of memory. So this was for generator functions, and we'll see in a second how to use them very effectively.